You look up. 2 bright dots hang in the twilight, closer than they should be. Not stars, too bright, too steady, planets. And in a few hours they will touch, or seem to. The distance between them shrinks with each passing minute. Most people walk past without noticing. They are scrolling, driving, eating dinner, but you're watching something that happens once in a human lifetime, maybe less. A conjunction so rare that the last person who saw it is dust, and the next person who will is not yet born. Their name will be different, their language might be different, but they will look up at the same 2 planets doing the same dance. We're not talking about the moon sliding past Jupiter on a random Tuesday. That happens every month. We're not talking about Venus in the evening sky. That happens every 8 months. We are talking about the events that make astronomers set alarms for 4 a.m., that make you drive 3 hours to dark skies with a thermos of coffee and a notebook, that make you wonder if your great-great-grandchildren will remember your name when it happens again. These are the 7 rarest types of naked-eye double-planet conjunctions you can witness in your lifetime. Some you have already missed. Some are coming in the next few decades. And one is so rare that no living human has ever seen it, and you will not live to see it either, but someone will. And when they do, they will think of us. This script is researched and factual, using sources from the Jet Propulsion Laboratory's DE-430 Planetary Ephemeris, published in 2025, and peer-reviewed astronomical databases, including Project Pluto's Mutual Planetary Occultation Catalog, compiled by astronomer Steve Albers, which tracks every planetary transit and occultation between 1700 and 2200. These are not generic skywatching guides. These are the receipts. Now back to the information. The last time one planet passed directly in front of another, visible from Earth, was January 3rd, 1818. Venus crossed in front of Jupiter just before sunrise, somewhere over the remote stretches of the Pacific Ocean or the Indian Ocean. No detailed observational records survive from that day. Scholars believe only people in remote ocean locations, sailors on ships, or islanders on distant atolls might have seen it. And they did not write it down. Or if they did, those records have been lost to storms, fires, or simply the passage of 2 centuries. Before 1818, the previous Venus-Jupiter occultation was February 4th, 1570, almost 250 years earlier. Before that, September 14th, 1210, another 360 years back. Before that, mid-June, 2 BC. That is 4 documented events in 2,000 years. 4 times in recorded history when Venus and Jupiter overlapped in the sky. Between 1818 and 2065, there's a gap of 247 years, the longest drought of mutual planetary occultations in recorded human history. Think about that. Everyone born after 1818 and before 2065 will live and die without ever seeing one planet cross another. Not once. Your parents did not see it. Your grandparents did not see it. No one you know, or their parents, or their grandparents ever saw it. On November 22nd, 2065, Venus will transit across Jupiter's disk. Venus will measure 10.6 arcseconds in apparent diameter. Jupiter will measure 30.9 arcseconds. Venus will appear smaller, so technically this is a transit, not an occultation. But the effect is the same. One planet will slide in front of another like a black dot crossing the face of a street lamp. The geometry is perfect, the timing is precise, and the problem is brutal. The event occurs only 8 degrees west of the Sun. 8 degrees. That is less than the width of your fist held at arm's length. You will not see it with the naked eye. The sun's glare will drown it out. You will need a telescope with a solar filter, the kind used to observe solar eclipses. You will need to know exactly where to point it, and you will need to be in a location where the sun is above the horizon at 12:43 UTC. Best visibility is in the southern Pacific Ocean, parts of western South America and western Africa. New Zealand, maybe, parts of Chile and Peru if the weather cooperates, central and southern Africa. Anywhere else, the sun will be below the horizon, or the planets will be too low to observe through the atmosphere. The window is minutes, not hours. Venus will take about 15 minutes to fully cross in front of Jupiter. If clouds roll in, you miss it. If your equipment fails, you miss it. If you're in the wrong hemisphere, you miss it. And if you miss it, the next Venus-Jupiter occultation is September 14th, 2123. Another 58 years away. After that, October 8th, 2335. Another 212 years. After that, February 12th, 2912, another 577 years. These events cluster in tight groups separated by centuries of nothing. Why? Orbital mechanics. Venus takes 224.7 days to orbit the Sun. Earth takes 365.25 days. Jupiter takes 11.86 years. Their synodic period, the time it takes Venus and Jupiter to return to the same relative position as seen from Earth, is 398.88 days, just over 13 months. So Venus and Jupiter align in the sky roughly once a year. But for an occultation, 3 conditions must converge with ruthless precision. 1. The planets must share the same right ascension or ecliptic longitude. 2. They must be close enough in angular separation that one passes directly in front of the other from Earth's perspective. Not near, not close, in front. 3. They must not be lost in the sun's glare. This is where the math gets brutal. Venus never strays more than 47 degrees from the sun as seen from Earth. It is an inferior planet orbiting inside Earth's orbit, so Venus is always somewhere near the sun in our sky. Jupiter can appear anywhere. It orbits outside Earth's orbit, so it can be in opposition, directly opposite the sun, visible all night. Most Venus-Jupiter conjunctions happen when one or both planets are too close to the sun to observe safely. Maybe they align at inferior conjunction, when Venus is between Earth and the sun. Maybe they align at superior conjunction when Venus is on the far side of the sun. Either way, lost in glare. For an occultation to be observable, Venus and Jupiter must align when both are far enough from the sun to see, but close enough to the sun that their orbits intersect our line of sight at just the right angle. This happens so rarely that astronomers have calculated only 18 mutual planetary transits and occultations between 1700 and 2200, 5 centuries, 18 events. 9 involve Mercury as the occulting body. Mercury is fast and close to the sun, so it crosses paths with other planets more often. But it is also the hardest to observe. 8 involve Venus. Only 4 occur exclusively between superior planets like Mars, Jupiter, and Saturn. Venus and Jupiter dominate the list because they are the 2 brightest planets. When they align, people notice. But brightness does not guarantee visibility. The 2065 event is technically observable, but only with planning, equipment, and luck. No casual observer will stumble onto it. You will need to know it is coming months in advance. You will need to book travel to the right hemisphere. You will need a solar-filtered telescope set up and calibrated, and you will need clear skies. 1 cloud in the wrong place, and 247 years of waiting ends in failure. Before Venus transits Jupiter in 2065, about an hour and 20 minutes earlier, Venus will occult Ganymede, Jupiter's largest moon, at 11:24 UTC. Parallax will shift the timing by a few minutes, depending on your exact location on Earth. If you are in the southern tip of South America, maybe southern Chile or Argentina, you might catch it. If you are in southern Africa, you might catch it. From space, this would be spectacular. The Hubble Space Telescope or the James Webb Space Telescope could capture Venus crossing Jupiter's cloud bands in exquisite detail. From Earth, it is a fight. A fight against geography, weather, and the sun. Accused, tried, silenced. The 2 largest naked-eye planets appeared as a single bright object to many observers. This was the closest great conjunction since March 4th, 1623. That event was 9 years before Galileo published his controversial book arguing that Earth moves around the sun. The 1623 conjunction was not widely observed. It occurred too close to the sun, and telescopes were new. Before that, the last easily observable close great conjunction was March 4th, 1226, almost 800 years earlier. Medieval astronomers saw Saturn and Jupiter separated by less than 0.1 degrees. Chronicles from the period do not survive in detail, but the event was noted by Arabic and Chinese observers. The Great Conjunction is the rarest of all naked-eye planetary conjunctions. Jupiter takes 11.86 years to orbit the Sun. Saturn takes 29.46 years. Every time Jupiter overtakes Saturn, roughly 19.86 years pass. This is the average. Earth's orbit adds variance. Actual intervals range from 18 years 10 months to 20 years 8 months. Since the equivalent periods of other naked-eye planet pairs are all under 900 days, the Great Conjunction is the longest cycle. Very close conjunctions, under 10 arc minutes, are much rarer. Since 1200 AD, only 4 have occurred. 1623, 1782, 1858, 2020. The next Great Conjunction is November 4th, 2040. Separation will be 1.1 degrees. Much wider than 2020. The next close one, under 0.2 degrees, is March 15th, 2080. That is 55 years from now. After that, September 8th, 2199. These events cluster in what astronomers call a triangular pattern. Every great conjunction occurs roughly 120 degrees apart on the ecliptic. After 3 conjunctions, the pattern shifts by about 8 degrees relative to the fixed stars. This creates a cycle where close conjunctions repeat in similar parts of the sky every 600 to 800 years. The 2020 event was visible worldwide, but the best viewing was near the equator. Northern Hemisphere observers had a shorter window before the planets set below the horizon. In the United States, optimal viewing was around twilight from December 17th through December 25th. The closest approach was December 21st at 1820 UTC. If you missed it, you missed the best great conjunction of your lifetime. Cold, close, gone. Mercury magnitude minus 0.2. Both planets appeared in the western sky after sunset. Venus was easy to spot. Mercury was not. Mercury orbits the Sun in 88 days, the fastest of any planet. It never strays far from the Sun. When Mercury reaches maximum western elongation, it appears in the pre-dawn sky. When it reaches maximum eastern elongation, it appears just after sunset. These windows are brief. Mercury is visible for maybe 2 to 3 weeks at a time, a few times per year. Most people never see Mercury. It is the elusive planet. Venus, by contrast, is the third brightest object in the sky after the Sun and Moon. When Mercury and Venus align, the conjunction is striking, but Mercury is often too faint or too close to the horizon to see without binoculars. The May 28, 2021 conjunction was the closest visible Mercury-Venus conjunction until November 5th, 2033. That is 12 years. After 2033, the next comparably close one is not until late in the 21st century. The average interval between Mercury-Venus conjunctions is 1.599 years, or 583.9 days. But Mercury and Venus do not align in predictable patterns like Jupiter and Saturn. Mercury's orbit is eccentric and tilted. Venus's orbit is nearly circular. When they meet, the separation varies widely. Sometimes they pass within a degree. Sometimes they are 5 degrees apart. Conjunctions closer than half a degree are rare. The May 21, 2021 event was special because Venus was at a good elongation from the Sun, about 30 degrees, making it easily visible. Mercury was dimmer, but still catchable with binoculars. The planetary pair set about 1 hour, 42 minutes after the Sun. If you had a clear western horizon and looked 30 minutes after sunset, you saw Venus bright and obvious, with Mercury as a faint reddish dot below it. Over the following nights, Mercury climbed higher and Venus descended, and by May 31st, they had swapped vertical positions. These conjunctions matter because Mercury is hard to tick off the planetary bucket list. Most casual stargazers never see it. A close conjunction with Venus is one of the best opportunities. You have Venus as a beacon and Mercury hiding in its glare. The next good one is November 25, 2025. Mercury will pass just above Venus in the east-southeast sky before dawn. Mercury will be at magnitude minus 2.1. Venus will be at magnitude minus 3.9. Both will be low on the horizon, so you need a clear view to the southeast. The separation will be close, under 1 degree, making this a strong viewing opportunity. But the 2021 event was closer, and we will not see another one that tight until 2033. 3-word punch: dim, close, brief. But most Mars-Saturn conjunctions are not particularly close. They pass within a few degrees and move on. Conjunctions under 1 degree are uncommon. April 2nd, 2018, separation, 1.3 degrees. Mars and Saturn appeared together in the pre-dawn sky, rising about 90 minutes before sunrise. Mars was ruddy, Saturn was golden. Both were easily visible to the naked eye, and they fit within the same binocular field for a week. The last Mars-Saturn conjunction before that was August 25th, 2016. The next one, after April 2018, was March 31st, 2020. The pattern is consistent, roughly 2 years between events. But closeness varies. Some conjunctions have separations of 3 or 4 degrees, others are under 2 degrees. The tightest ones, under 1 degree, happen maybe once every 10 to 15 years. What makes Mars-Saturn conjunctions rare is not frequency, but context. Conjunctions between 2 superior planets, those orbiting farther from the Sun than Earth, are easier to observe than conjunctions involving Mercury or Venus. Mars and Saturn can both appear in opposition to the Sun, meaning they are visible all night. No glare problems, no horizon issues. The rarity comes from having both planets bright and well-placed at the same time. Mars varies wildly in brightness depending on its distance from Earth. At opposition, Mars can shine at magnitude minus 2.9. At conjunction with the Sun, it fades to magnitude plus 1.8. When Mars and Saturn conjoin, if Mars is near opposition, the event is spectacular. If Mars is far from Earth, it is dim and unimpressive. Saturn is more consistent, always around magnitude plus 0.5 to plus 1.0. The closest Mars-Saturn conjunctions occur when Mars is in its retrograde phase and Saturn is near opposition. This happens roughly once every 15 to 26 months. The geometry is complicated by Mars's eccentric orbit. Between 2 superior planets, conjunctions occur about once every 10 years on average. But those featuring only bright naked-eye planets, Mars, Jupiter, or Saturn, are extremely rare, once in a century at most. Most conjunctions between superior planets involve at least one dim outer planet like Uranus or Neptune. A triple conjunction of Saturn and Neptune is happening in 2025 and 2026. First conjunction, June 29th, 2025. Second conjunction, August 6th, 2025. Third conjunction, February 16th, 2026. But Neptune is magnitude 7.8, too faint for the naked eye. So this triple conjunction does not count for our list. The next truly rare Mars-Saturn conjunction will be one that coincides with Mars at perihelic opposition, when Mars is closest to the Sun and brightest. Those happen every 15 to 17 years. If Mars and Saturn align during one of those windows, the separation is under half a degree, and Mars is magnitude minus 2.9, you have a once-in-a-generation event. Watch for it. Bright, slow, patient. Both planets appeared in the western sky after sunset. This was the best Venus-Jupiter conjunction until September 2nd, 2039. Venus and Jupiter are the two brightest planets. When they come together, they dominate the evening or morning sky. The average interval between Venus-Jupiter conjunctions is 13 months, or more precisely 398.88 days. That is the synodic period of Jupiter. So Venus and Jupiter align roughly once a year, but the separation varies wildly. Some conjunctions are 10 degrees, some are 3 degrees, some are under 1 degree. Conjunctions closer than the width of the full moon, about half a degree, are rare. The March 1st, 2023 event had Venus and Jupiter separated by 0.5 degrees. From Earth's perspective, they appeared as two bright objects within the same binocular field, almost touching. The actual distance between them in space was over 600 million kilometers. Venus was about 0.7 astronomical units from Earth. Jupiter was about 5.2 astronomical units from Earth. The illusion is pure geometry. Venus, Earth, and Jupiter happened to line up so that from our vantage point, the two planets overlap. Over the next few nights after March 1st, Venus and Jupiter separated. By March 5th, they were over a degree apart. The window was short. Venus-Jupiter conjunctions cluster in families, separated by about 3 years and 3 months. This is because Venus's synodic period is 1.6 years, and Jupiter's synodic period is 1.09 years. So every 3.2 years, Venus returns to the same position relative to the Sun. Jupiter returns to the same position in 3.27 years. Close enough that similar conjunctions repeat, but they drift. Over time, the morning conjunctions move closer to the Sun, and the evening conjunctions move farther from the Sun. Then, the pattern resets. The March 1st, 2023 conjunction was part of a series that began decades earlier. The next similar one, in the same part of the sky, will occur about 24 years later. Check the math. Multiply Venus's sidereal period, 224.7 days by 39, equals 8,763.3 days. Multiply Earth's sidereal period, 365.25 days by 24, equals 8,766 days. Multiply Jupiter's sidereal period, 4,332.58 days, by 2, equals 8,665.16 days. Close enough that Venus, Earth, and Jupiter return to nearly the same relative positions every 24 years. The conjunctions get progressively closer with each 24-year cycle. The closest observable Venus-Jupiter conjunction this century will be September 4th, 2121. Separation, 0.13 degrees, about 1/4 the apparent diameter of the moon. But it will be low in the dawn twilight, making it a challenge to observe. If you miss it, the next best one is not until the 22nd century. The February 12th, 2056 conjunction will have Venus and Jupiter separated by only 0.1 degrees, but at just 16 degrees above the horizon, it will be nearly impossible to see. On November 22nd, 2065, Venus will occult Jupiter, but that is the same event we covered in number 1. The point is this: Venus-Jupiter conjunctions happen every year, but the really tight ones, under half a degree and well-placed for viewing, happen once or twice in a human lifetime. If you saw the March 1st, 2023 event, you saw one of the best, bright, close, together. If you value documented astronomy like this, subscribe. It is the best way to support our work. Also, comment from which city you are hearing this from. This script is researched and factual, using sources from Rice University's Venus-Jupiter conjunction analysis, published by astronomer Patrick Hartigan in November 2024, which provides observational data and mathematical modeling for every Venus-Jupiter conjunction between 1980 and 2070. Also using the Starwalk Planetary Conjunction Database, updated November 2025, which tracks separation distances and elongation angles for all naked-eye planetary conjunctions visible from Earth. Now back to the information. Jupiter magnitude minus 2.8. Both planets appeared in the eastern sky before dawn. This was the closest Mars-Jupiter conjunction since May 26, 929. That was 1100 years earlier. The Mars-Jupiter synodic period is about 2.23 years, or roughly 815 days. So Mars and Jupiter align roughly every 2 years, but the closeness varies. Most Mars-Jupiter conjunctions are separated by 1 to 3 degrees. Conjunctions under half a degree are rare. Since the year 2000, only 11 Mars-Jupiter conjunctions have occurred. The August 14, 2024 event was the tightest of them all. Mars and Jupiter were separated by just 1/3 of a degree, less than the width of the full moon. Both planets were visible to the naked eye as bright points of light in the early morning sky. For those using binoculars or a small telescope, both planets fit within the same field of view. Despite their apparent closeness, Mars and Jupiter were separated by about 300 million miles in space. Mars was about 1.5 astronomical units from Earth. Jupiter was about 5.2 astronomical units from Earth. The illusion is perspective. On August 14th, the two planets shared the same right ascension as seen from Earth. Over the following nights, Mars sped past Jupiter and moved eastward along the ecliptic. By late August, they were several degrees apart. The next Mars-Jupiter conjunction is May 29th, 2026, but the separation will be wider, over 1 degree. The next really close Mars-Jupiter conjunction, under half a degree, is not until 2033. After that, the pattern resets. Mars and Jupiter conjunctions follow a rough pattern. Every 39 to 40 months they align. But the tightness depends on Mars's eccentric orbit and Jupiter's position. When Mars is near perihelion, closest to the Sun, and Jupiter is near opposition, the conjunction can be very close. If Mars is near aphelion, farthest from the Sun, the conjunction is wider and less impressive. The August 14th, 2024 event was optimal. Mars was bright, though not at its peak. Jupiter was near opposition, shining brightly. The separation was minimal. If you set your alarm and went outside, you saw 2 bright planets almost touching in the pre-dawn sky. If you missed it, the next opportunity is a decade away. What makes Mars-Jupiter conjunctions rare is not just frequency, it is context. Mars and Jupiter are both outer planets relative to Earth, so they can be observed all night when near opposition. No sun glare, no horizon limitations. But Mars's orbit is eccentric, and its brightness varies by a factor of 100 depending on distance. Jupiter is consistent, always bright, but it moves slowly. The alignment of a bright Mars and a well-placed Jupiter with a separation under half a degree happens maybe once every 50 to 100 years. The last one was 929. The next one is 2033. Then a long gap, fast, red, giant. Mars, magnitude plus 0.8. Both planets will appear in the pre-dawn sky, low on the eastern horizon. This is the rarest pairing on this list for one simple reason. Mercury and Mars almost never meet. Mercury orbits the Sun in 88 days. Mars orbits the Sun in 687 days. The synodic period of Mercury and Mars is about 130 days, so Mercury and Mars align roughly every 4 months. But Mercury is only visible for a few weeks at a time, a few times per year. Mars moves slowly. Most Mercury-Mars conjunctions occur when Mercury is lost in the Sun's glare. The times when Mercury is visible and Mars is nearby, well placed for observation, are vanishingly rare. The October 19th, 2025 conjunction is one of those rare windows. Mercury will be near maximum western elongation, meaning it will appear in the pre-dawn sky at its farthest point from the Sun. Mars will be in the same region of the sky, moving eastward. The separation will be close, under 1 degree, making this a strong viewing opportunity. But the challenge is altitude. Mercury never climbs high above the horizon. Even at maximum elongation, it is only about 26 degrees from the Sun. At dawn, it appears low, maybe 10 to 15 degrees above the horizon. Mars will be slightly higher. Both planets will be faint compared to Venus or Jupiter. You will need a clear eastern horizon, minimal light pollution, and binoculars to catch them. The rarity here is not just closeness, it is the pairing itself. Mercury and Mars, conjunctions visible to the naked eye, are so rare that most astronomy databases do not even track them. The next Mercury-Mars occultation, where Mercury passes in front of Mars, is August 11th, 2079. That event will occur only 11 degrees from the Sun, making it nearly impossible to observe. The occultation will last 2.5 minutes, visible only near east longitude 50 degrees before sunrise. A likely location is the western shore of the Caspian Sea in Georgia or Iran. After 2079, the next Mercury-Mars event is decades later. The rarity of Mercury-Mars conjunctions is structural. Mercury moves fast, but is trapped close to the Sun. Mars moves slowly and can appear anywhere. When their paths cross in a part of the sky where Mercury is visible, it is an accident of geometry. Most conjunctions happen when Mercury is in superior conjunction with the Sun, on the far side, invisible. Or when Mercury is in inferior conjunction, passing between Earth and the Sun, also invisible. The windows are narrow. The October 19, 2025 conjunction is one of those windows. If you want to see Mercury and Mars close together, this is your chance. The next one might not come for another 10 to 20 years, and the next one that is both close and well placed for observation might not come in your lifetime. Elusive, fast, rare. And they will look up at the same sky, the same planets, following the same orbits that have been locked in place for 4.5 billion years. But here is the reframe. Here is what changes everything. On November 22nd, 2065, someone will stand on a beach in New Zealand or a hillside in Chile. They will be 40 years old, maybe 50. They will have a telescope with a solar filter clamped to the eyepiece. And they will watch Venus, a bright dot, slide across the face of Jupiter. For 15 minutes, they will hold their breath, they will take photographs, they will record video, and when it is over, they will sit down in the sand or the grass and they will cry. Not because it was beautiful, though it was, but because they will remember that on December 21st, 2020, when they were 5 years old or 10 years old, someone told them about the Great Conjunction. Someone, a parent or teacher or an aunt or a stranger at a star party, dragged them outside in the cold December evening and pointed at two bright dots in the southwestern sky and said, "Look, those are Jupiter and Saturn. They are closer tonight than they have been in 400 years. You will never see them this close again." And the child looked and did not understand, but they remembered. And 45 years later, standing on that beach or that hillside, they will realize that the events are connected, that the planets are not random, that the sky is a clock, and the clock has been ticking since before the first humans looked up. The orbits of Venus, Jupiter, and Saturn were set in motion when the solar system formed from a collapsing cloud of gas and dust. The angles, the speeds, the distances, all determined by gravity and momentum. And those orbits have not changed, not in any way that matters to us. Venus has orbited the Sun 1,840,000,000 times. Jupiter has orbited 380 million times. Saturn has orbited 160 million times. And every 19.86 years, Jupiter laps Saturn. Every 398.88 days, Venus passes Jupiter. Every 247 years, Venus transits Jupiter. The clock is winding down, but not in the way you think. The clock is not running out. The clock is just ticking. In 2121, someone will wake up at 3:30 a.m. in a city that does not exist yet. They will drive to a dark site, a place where the light pollution has been pushed back by regulations or technology or collapse. And they will set up their binoculars and point them at the eastern horizon, and they will see Venus and Jupiter separated by 1/4 the width of the moon, closer than any conjunction in modern recorded history. And they will know because someone told them that the last time it was this close, their great-grandparent was not yet born. Maybe their great-great-grandparent. The dates will blur, but the knowledge will remain. Someone saw this before. Someone will see this again. In 2079, on August 11th, someone will fly to Baku, Azerbaijan, or drive to the western shore of the Caspian Sea in Georgia or Iran. They will arrive 2 days early to scout the location. They will set up their equipment on a beach or a rooftop, and at 1:26 a.m. UTC, they will point their telescope 11 degrees from where the sun will rise in 3 hours. And for 2.5 minutes, they will watch Mercury, the fastest planet, cross in front of Mars, the red planet. The occultation will last 150 seconds. Mercury will be magnitude plus 1.2. Mars will be magnitude plus 1.5. Both planets will be dim, barely visible even through the telescope, but they will be there. And for those 2.5 minutes, the observer will be the only person on Earth, possibly the only person in the solar system watching this event. No one else will have the right equipment in the right place at the right time. No one else will have planned for it. And when it is over, the observer will pack up their telescope, drive back to the hotel, and write a report that 17 people will read. But those 17 people will remember. These are not just conjunctions. These are not just dots in the sky. These are markers, monuments, evidence. The planets do not care if you watch. They do not care if you remember. They do not care if you write it down. But the people who do watch, who do remember, who do write it down, they care. They pass it down. They build the databases. They write the papers. They compile the catalogs. And someday, when you are gone, when your children are gone, when your name is forgotten, someone will look up at two bright dots in the sky. And they will wonder if anyone before them ever saw what they are seeing now. The answer is yes, you did. Someone in 1818 did. Someone in 1226 did. Someone in 2 BC did. And you knew it was rare. You knew it mattered. Not because the planets care, but because we do. The sky is full of clocks. The Great Conjunction ticks every 20 years. The Venus-Jupiter conjunction ticks every 13 months. The Mars-Jupiter conjunction ticks every 2 years. But some clocks tick slower, some clocks tick once in a human lifetime. And some clocks tick so slowly that no human life is long enough to hear 2 ticks. We are the ones who build the record. We are the ones who remember. We are the ones who look up at 2 dots in the sky and say, "That is rare. That matters. I am witnessing something that will not happen again for 200 years." And we are right, because rarity is not just math. Rarity is context. Rarity is memory. Rarity is the knowledge that you are standing at a specific point in time, looking at a specific configuration of planets, and that configuration will not repeat in your lifetime. And knowing that changes how you see it. You do not just see 2 dots. You see 4.5 billion years of orbital mechanics. You see the solar system functioning exactly as it has always functioned, indifferent to us, perfect in its repetition. And you see your own mortality, because the planets will be here long after you're gone, and they will align again, and someone else will watch, and they will think of you, even if they do not know your name. That is what these 7 conjunctions mean. That is why they matter. Not because they are pretty, not because they are rare, but because they connect us to the people who came before and the people who will come after. The observer in 1818 who saw Venus cross Jupiter did not write it down, but we know they existed. We know they saw it, because the math says so. The observer in 2065 will write it down. They will take photographs. They will post them online, or whatever comes after online, and someone in 2335 will see those photographs and realize that they are next. The chain is unbroken. The sky is the same. The planets are the same, only we change. So when you look up at the next conjunction, whether it is October 19, 2025, or November 4, 2040, or March 15, 2080, remember this. You are not just watching planets. You are joining a chain of observers that stretches back to the first humans who looked up and wondered. And you are passing that chain forward to the humans who will look up after you are gone. But that is the real rarity, not the planets, us.